Hi, we have AP Physics 1 past paper 2024. We are discussing the section free response questions. In this section, we have the question number 5 which carry the 7 points. At time t0, the block A slides along a horizontal surface toward the block B, which is initially at the rest, mean initial velocity of the B is equal to 0. So what happened? The masses of blocks A and B are 6 kg and 2 kg respectively as shown in a fig. The block B collides elastically with at 1 second. As the result, the magnitude of change in kinetic energy of the block B is 9 joule. Now, all frictional forces are negligible. Determine the speed of block B immediately after the collision. Now, as we come to know, there is initial velocity 0, so there is no initial kinetic energy after the impact because the elasticity is there, elastic collision is there. We conclude kinetic energy change final minus initial. We have the 9 joule final energy of the block B, so kinetic energy we replace with 9 joule. So find initially we replace the value of all things. The initial velocity is 0, so that's case we place here is 0. So this whole factor disappear from here. Now we have the values, and we can convert the unit of joule into SI base units. Kg is cancelled through kg. Now 2 can be cancelled from 2. Vb square is equal to 9 meter square per second square. On square rooting both sides, we can answer Vb finally 3 meter per second. Now, the graph shows a fig to represent the position x of block A and block Y and the center of mass block to block system as a function of t at t0 to t1. On a graph in fig 2, draw and label three lines representing the position of block A, block B, center of mass of the two block system as a function of t between t0 to t1 to t2 second. Each line should distinctly labeled. Okay. Since first of all we have discussed that since collision is elastic, both momentum and kinetic energy is conserved. After the collision, there is no frictional force. Each move with constant velocity, straight line position graphite. Motion of the block B. Well, we have finally find the value of the final velocity of the block B, that is the 3 meter per second. At time t1 to t2, we find the distance delta x is equal to v delta t. Velocity is constant. Time is interval is 1 second because this is the 1 second interval. So all the discussion is through the time interval is 1 second. So that's the 3 meter. So that's we can see the block B is final position is 2 meter initial, 3 meter finally. So that's the 5 meter position. That's the 5 meter. So that's why it is from 2 to 3. Now, the motion of block A, first of all, we find the initial slope of the graph delta x over delta t 2 over 1, that's the 2 meter per second, that's the initial velocity of the block A. Now, after the impact, we law of conservation of momentum, initial the block B is 0, so that's why it is 0. Now, we place all the values, initial final velocity of the block B we have now, we come to find final velocity of the block A, that is the 1 meter per second. So its mean at starting point x is equal to 2 meter. That is the this point. We come to the block A move 1 meter in 1 second. So after t2 second, the new position will be from 1 meter add 2 plus 1, that is equal to 3 meter. So new position of the block A is 3 meter. Now motion of the center of mass, again we find the slope of the line delta x over delta t, that is 1.5 meter per second. Center of mass move with the constant velocity when no external force acts. The collision doesn't affect the center of mass motion. The center of mass line must continue unchanged. So initially we conclude 1.5 meter in 1 second. It is the velocity initially. So velocity, there is no change in velocity. So after 2 meter, it further cover the distance in 1 second, 1.5 meter. So total distance at the end is 3.5 meter. So that's why it hit between the 3 and the 4, 3.5 meter. Now, if they consider the original scenario, instead of colliding elasticity, the block collides stuck together, mean inelastic collision. Describe how the line drawn the center of mass in part A would change if at all. Just justify your response. Center of mass velocity depends upon the total momentum of the system, which is conserved in collisions. Mean either the collision is elastic or inelastic, total momentum is always remains constant or conserved. So there is no external horizontal force. The velocity of the center of mass remains constant. Therefore, line drawn from the center of mass in part B would not change. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.